Hello everyone. In this second part of the video about the multi-agent programming contest, we're going to discuss the starter code and how can you start your solution for assessment 3. So here we have the folder for the contest. You go into starter kits. You see you have JSON dummy A, JSON dummy B. Okay, JSON dummy B is only there for you to test running two teams at the same time, right? Because that's how the competitions will actually run. But you don't really need to change or do anything with this folder over here. The one you want to copy is JSON dummy A, right? Now, to run a team, they don't have to be inside the contest folder, right? So they don't need to follow this folder structure at all. You could copy this into, I don't know, something else like GitHub. I'm gonna copy it here, and I'm gonna rename it to um, the name of your team, right? So I don't know. Let's say the name of my team is Liverpool, just because originally when I participated in many competitions, I was at the University of Liverpool. So let's say, well, now I'm in Aberdeen, right? So let's say my team is called Aberdeen. I think that's more in line here. And then I can just make the changes I want inside here. All right. So again, you don't need to start changing this file inside of this folder here, right? And why am I telling you this? I've seen some of the GitHub repositories, they've actually uploaded everything, like including the server there. While this is not technically wrong, right? This server can change, and in fact, when testing, many of your team members may be doing different changes to the server, right? By, I don't know, changing the initial obstacles, right? By changing this file over here. Or they may be, I don't know, doing other changes to the server, and you don't, I don't think it's a good idea to have the server inside your repository. What you want in your repository for your team is just the team agent, right? Which again, you can copy it somewhere else um, outside of the server and then just run it from there, all right? Without making any further changes. Just make sure you are in this folder when you're running this agent, right? And with another terminal, you will be in the server folder running the server. All right, once you have that, the only file you really need to focus on, at least at the start, will be this one here, connection A. You don't have to rename it or anything. You can if you want. We will rename it to have you match your team when we are running the contest anyway. So you don't need to worry about that. But you will want to open that file and start changing this file over here. Before we discuss it, we have the configuration file here. You shouldn't change this, right? Keep it like it is. It's just telling you that you have 5 agents and they will all be using this file over here, connection A. Right? So you have connection A1, connection A2, and so on. So you don't need to change anything here. There's an environment. We'll talk about it later. We'll start with the agent. All right. In the previous video, you saw me running the dummy, and perhaps you have already run it yourself. And you saw that the agents were moving randomly through the map. And that's all this dummy starter code does. All right. So it has a initial belief rule, right? Belief-based rule. It has an initial goal start, where it's just printing things, really. It doesn't do anything. It's just printing something on the screen. So you don't, on your code, you won't really need these, right? But I just added it there just to have some feedback on the screen in case you get some other error or something. Then it will start when it receives these perceptions over here, right? Step and action ID. Now, when you receive step, it's just printing that it has received a step percept, all right? It's not doing anything. It is acting when it receives the action ID. Now, this is because the order of the perceptions, action ID is one of the first, so it's usually best to act based on this belief, right? You could act, but the way you decide on sending your actions can be different, right? You can act based on, I don't know, other beliefs or something, but you should be careful to avoid sending more than one action from the same agent within the same time step. All right, there are many different ways you can try to solve that problem, but the best way is to just avoid doing that while programming your agent, right? So just ensure it's not possible for your agent to be sending two actions for the same step. Okay, this particular agent here, when it receives the action ID for a particular, time step, there's nothing to check. The context is always true. Then the agent just prints something for debugging purposes that is determining its action. And the action that that agent will do is move random. Could uncomment this and comment this, and now all the agent will do is skip, right? And I can demonstrate this one quickly to you. If we run the server and we run the agent, and you can see the agent is connected, the steps are progressing very quickly, but the agents are not moving. And if we scroll through one, you can see there on the left side, it says skip as the action of the agent. Okay, so now the agent is skipping every action without doing anything. This move random here, however, is deciding direction to move randomly. Okay, the way it's doing this is this plan over here. But first, it's adding the goal, right, which will trigger this plan. And then we check a couple of things in the context. First, we will use an internal action from JSON called .random. You can check how this works using the API, which is part of the slides for the JSON lecture. Remember that I told you that the API is very important, especially for the internal actions. Have a look there. You will see exactly what this does here, right? But basically, it's going to return a random number, right? And that random number will be between 0 and 1, okay? And we are saving that into this free variable called random number. Then I'm calling my belief-based rule, random dir, that I have at the beginning here, where I'm passing a list with the possible directions that I want to choose randomly, north, south, east, and west. I'm passing the random number that I generated between 0 and 1, and I'm passing a free variable dir that will be unified by this rule with one of these four based on the random number that was generated. Finally, I will have one of these four unified or assigned to this free variable. And then in the body of the program, I will call the action in the server to move to that direction, which again will be either north, south, east, or west. Extremely simple, right? I will briefly go through the rule that we have here, random dir. Again, we have the list of directions, which has been unified, the random number, which has been unified, and a direction, which is a free variable. Now in this rule, you will see I have four different possibilities. First, I'll check if the random number is less than or equal to 0.25. Remember, it's between 0 and 1. If it is less than or equal to 0.5, I will then use another internal action, which is called the ant or nth internal action. Again, you can look at the details in the API. But basically what it does is I will inform a list index, right? The position, uh, the index position of a list inside of a list. The list itself and a free variable, which will then unify with the member, the element within that index position of that list. So in other words, all I'm saying here is that if the random number is less than or equal than 0.5, I will choose the first element, element 0. Remember, programming, basic programming languages all do it like this, right? The list starts as 0 instead of 1. So I'll choose the first element in my list. Remember what their list is? It's north, south, east, and west. So I'll pick north is what I'm saying with that code there. And I'll unify that, the free variable here, right? And return it here. And then I'm going to move north. However, if the number is not less than or equal than 0.25, I'll check if that number is less than or equal to 0.5, right? So what you can see where I'm getting with it, where I'm going with this. I have a 25% chance of choosing north, a 25% chance of choosing south, right? Position 1 of the list. 25% chance of choosing east, and another, well, the remaining one, right? If it's not any of the other ones, then it has to be the last one, which is east, which would be another 25% as well. And you can see I'm separating all of those with the OR symbol, which in JSON is represented by the vertical bar, vertical line here. Okay, so it will either be this, which will be north, or this, which will be south, or this, which will be east. And if it's not any one of those, then it has to be west, which is the last possible option. And that's all this initial code does. So I gave you plenty of tips about strategies, right? You want to think about how you want to explore your map at the start when the agents don't have any information apart from what they're seeing locally. Perhaps you want to build local maps of the agents so they can keep track of what they see. Perhaps when your agents meet, you want to merge their local maps into a global map. Perhaps you want to make a protocol for agents to identify themselves or each other when they see them in the map, right? When they become visible in the map to one another. Perhaps you want to focus on making tasks with multiple blocks, right? And coordinating agents in order to do tasks with multiple blocks. Remember, you need more than two. Perhaps you want to focus on tasks with only one block and make that extremely efficient, right? Up to you. Perhaps you want to do all of the above and win the multi-agent program competition. Up to you again. If you have any questions, feel free to reach out to me. Now, in the rest of this video, I'll briefly go over the environment that we have, which you won't have to change unless you're looking for very, specific things and how to deal with information coming from the environment. But in most cases, you won't have to bother with that. But before we talk about the environment, I will briefly talk about this other file here. Where can you find eismassimconfig.json? Not to be confused with JSON, two different things. So if you go into your starter code or the one you copied and you go into conf folder, you will see that file here, right? This is the file I have open here. Why is this one important? Well, you don't want to change anything here. This is to do with the connection to the server. However, these over here may be relevant to you. Now, in most cases, you won't have to change these, but depending on the approach you want to implement your agents with, right? Either more reactive or more proactive. You may want to play around with these flags and change some of them to true, right? What do they do? So I don't want to confuse everyone else. So you should, if you come to that point where you think these will matter to you, you go to the documents folder, right, on our repository for the server, and you go into EIS Masim and scroll down to configuration. So you'll see it looks very similar to what we have here. And you'll find the scheduling, the times, notifications, and queued here. And you'll have the explanation of them here, right? So scheduling, if true, an action can only be sent if an action available ID is available, right? So it is saying it's not recommended to disable this, and in ours it is disabled, right? That's for specific reason, right? You will notice if you start playing around with it. Then you have things like queued, if enable, get all percepts, will only send one collection of percepts for each call in the same order that they were received, right? Otherwise, they will be refreshed every step, right? So right now it's set to false, so it's refreshed at every step. So you probably don't want to mess around with notifications. You want to keep that one false, unless you have something on the environment that will make use of this. Times, you also don't need it, unless again you need the annotation of the time when things were generated by the server. More likely not, right? You won't need this. So the only two really are queued and scheduling that may make a difference on how you develop your solution. So they are false for a reason, right? It's what I recommend, but depending on the type of solution you do, you may want to change them to true and see if that helps with your solution or not. See the impact that does for you. Now the last thing is the environment, right? Not gonna go into too many details here. You don't have to touch this, right? It's basically the thing that is going to connect to the server, right? So it's just basically instantiating the configuration file that we just went through. Then it will check if it has started, right? If the connection is active, the port is active for connecting to the server. Then it will try for each new agent to try to connect it to that particular server and attach an environment listener. Let me remove this one here. And and right, and then for each agent, we'll be registering it to the server. So this is the thing that will actually trigger the connection. We will catch some exceptions if there are any problems, and then we'll attach an agent listener that will return the perceptions for each agent individually. All right. Then we have just a general function here that will handle the percepts. Another function which will get the perceptions. So we can see here we create an array list. We first clear the perceptions of that agent, the current perceptions of that agent. Then if the environment is not null, we manage to connect, right? This is what it is saying. We will get them as a map, right? We will get all the perceptions of that particular agent. So each agent only has its own perceptions. Then we'll create those perceptions and finally add them to the belief base of the agent. And then we have our function to execute the action, which again, it just simply executes whatever is the the external action that we send to the agent. There's no checks here, right? So if you send a wrong action, it's just gonna fail, basically, right? Returning false here. We have a stop to stop the system. Then we have some translations. Now these ones you definitely don't want to touch, right? They are just translating from percept to literal. So literal are the things that we can use to add like terms um, for each of the predicates that we have in our belief base and so on. And then we also have another one to translate from parameter to term, right? Again, can have numbers, strings, lists, and so on. And then finally, we have the other way around as well, right? Literal to action and term to parameter. So we don't want to touch these functions here. If any function, if there is any method here that you may, possibly want to think about customizing it, is get percepts. Right? If you can think of something to do with the perceptions that are coming from the environment before you add them to the belief base, this will be the one that you can look into it. The rest, you don't and shouldn't be changing. And even then, you don't really need to change this. It's just really if you can think of something else that you can do here in order to improve things or make it work for your agent. Of course, you can always create new things in the environment as well, right? So you could create like I wouldn't suggest when creating a map for your agent that you keep that into the belief base of the agent, right? You can if you want to. Another alternative is to just create a map structure in Java, right? Which is a little bit easier to manipulate and save, and use the environment to save that information and update that information using the agent, right? You can also create internal actions for your agent, like we saw in class. So there are alternatives here, but it's not mandatory that you will have to use this Java file. It's just an additional asset that you can make use of. All right, that concludes the videos for the multi-agent programming contest. I know it's not simple, right? It's a complex problem, but that's the point of the assessment. It's supposed to be complex, right? It's a group project. If at any point you have any questions about the programming contest, please feel free to reach out to me. All right. Like I said, there will be at least 1 hour in our next practical session dedicated to questions about this. So hopefully you have some then. Um, if later you have any other questions, you can always email me and we can either deal with it through email or we can set a time to meet as well. Thank you very much for your attention, and I hope this was helpful to you.